So for Part D of the chromatography lab, we are going to be using column chromatography to separate a mixture of fluorine on the left there and fluorinone on the right. And the reason why this will work is because there's a difference in polarity between fluorine and fluorinone. You can tell just by the functional groups that are present in those that there's a difference, that fluorinone is more polar than fluorine is. So because of the fact that fluorinone is more polar than fluorine, it'll adhere more strongly to the silica gel. It'll interact more strongly with it. And so it'll be harder for it to be pulled off of the silica gel, which is also polar. So just to give you an idea of what we're doing, I want to talk through it really quickly just because it'll make a little bit more sense, hopefully, what you're actually looking at as I do the experiment. So we are going to construct a column out of a pipette. And for the first, we're going to collect the elution, the stuff that elutes off of the column, in 4 separate test tubes. These are called fractions. So fraction 1, fraction 2, fraction 3, and fraction 4. So fraction 1 will be simply hexane. I've shown that 3 milliliters of hexane, the silica gel in black, and then there's a cotton plug in the bottom just to hold in the silica gel of the column. So you'll load 3 milliliters of hexane through the column and collect that down in test tube number 1. Now there's nothing in that test tube because we haven't actually loaded our compounds yet, but we have to run solvent through the test tube first, or excuse me, through the column first to make sure that our silica gel is nice and well packed. Then we will load the fluorine and fluorinone mixture. I've put that in sort of a reddish color there, and elute that with 6 milliliters of hexane. That will go into test tube number 2. And 6 milliliters of hexane, hopefully, that will elute the fluorine off of the column because the fluorine is not very polar. So we can use a relatively nonpolar solvent to get it to elute off of the silica gel. So only fluorine will elute and collect in test tube number 2, hopefully. So after we've eluted 6 milliliters of hexane through the column, we will then switch to 70% hexanes, 30% acetones, a little bit more polar of a mixture there. When we do that, the colored fluorinone will begin eluting from the column. I've sort of represented that in red there. And we'll be collecting into test tube number 3. Now test tube number 3 hopefully shouldn't have anything in it because we've collected all of the fluorine in test tube 2. In test tube 3, and the fluorinone hasn't eluted off of the column yet. Then we'll switch to test tube 4. That will be also with 30% hexane, or excuse me, 70% hexane, 30% acetone. The fluorinone will elute off of the plug, off of the column, and we'll collect that in testing number 4, which hopefully should have pure fluorinone in it. So after that, we'll analyze our fractions by TLC. We'll spot fractions 2, 3, and 4, and then we'll also take a melting point of the stuff that we get out of fraction 2 and fraction 4 to hopefully demonstrate that it is pure. So here's everything that I need to run this column. I have my column set up here. I don't know if you can quite see it, but there's some cotton in the bottom here that's holding this silica gel in. The silica gel is still dry, and it's just in a normal Pasteur pipette. I also have my fluorinone mixture here. I've measured out 0.3 milliliters of that. I have my hexanes, which is the first solvent that I'm going to use. I've measured out 9 milliliters of that. And I have my 70% hexanes, 30% acetone, about 10 milliliters of that, which I've measured out. I also have my numbered test tubes, 1, 2, 3, and 4, and a couple of Pasteur pipettes with bulbs so that I can transfer the solvent into the Pasteur pipette, or excuse me, into the column relatively easily. So now I'm going to start with collecting fraction number 1. I'm going to add 3 milliliters of hexane to my column here and just let it run through in a loop. So the thing that's really, really important about this when you're running these columns is that you never let this solvent up here run out. Because if this solvent up here runs out, your column will start running dry and it'll mess up the separation that you get in the elution of your compounds. which is the whole point why you're running the column, is so that you can separate out things. So once you start running it, you can't really stop. You can't walk away and do other stuff. You can't really multitask or anything. You have to pay close attention to the level of this solvent that's in the column so that, again, your column doesn't ever run dry. So we have about probably a milliliter of this in here. You can see the level is decreasing a little slowly. It hasn't actually stopped dripping into the bottom yet. Started dripping into the bottom, I should say. But I'll show you when that starts, and when this is dripping nicely, I'll just give you a shot of that just to see what that looks like. All right, so now it's dripping through. Try and zoom in, see if you can see that a little bit better. Yeah, see the hexane's eluting out of there. And again, this is still, I haven't added the compounds that we're trying to separate. All I'm doing is getting the column hydrated so that once we do add the compounds on top of it, then they will run through effectively and not onto dry silica gel. You always have to do this. This is a sort of a pre-loading procedure when you're running a silica gel column to wet the silica gel like this with whatever solvent that you're using. So I'm just going to let this 3 milliliters of hexanes run through here. And once that's totally done and run through, I'm going to go ahead and load my mixture of fluorine and fluorinone onto the column. Now the key thing about this is that I want to make sure that the level of the solvent in the column is right at the top of the silica gel. You want to make sure that there isn't any really excess solvent before you add your 70%, or excuse me, your mixture of fluorine and fluorinone. We want to add it once this level of this solvent drops to just right there. So I'll go ahead and wait for that to happen and give you a shot. Hopefully I can get to focus right of what loading a column looks like. So you can see the level of the solvent here is about at the very top of the silica gel. So I'm going to go ahead and load the mixture of fluorine and fluorinone now. Sucking it up with a Pasteur pipette. There's our mixture. I'm just going to go ahead and gently put it into the column like this. There we go. So now this is our mixture of fluorine and fluorinone again, and I'm going to let this elute to the top of the silica gel before I add any more solvent. The reason I do that is so that I don't dilute the mixture of fluorine and fluorinone, because if I added more solvent right now, I would just dilute this. But we want it to be in a very thin band at the top of our silica gel, so the way to do that is to make it in as much, or excuse me, as little solvent as possible when you load it. So my mixture of fluorine and fluorinone is right at the top of the silica gel now. So I'm just going to get ready to add more hexanes to it. Again, we're still just adding hexanes. We haven't switched to our more polar solvent. And this will elute just the fluorine from the column because it's the less polar component of the two. So I'll go ahead and get some fluorine, or excuse me, some hexanes in my Pasteur pipette. And add it to the column here. Very gently. There we go. So now I've loaded the mixture onto our column, and now we have to do is just manipulate the polarity of the solvent to get everything to elute off. So you'll see I'm also now collecting in test tube number 2, and this will be the case until I've run 6 milliliters of hexanes through the column. Okay, so I've run about 6 milliliters of hexane through my column. You see the yellow color is actually still at the very top of it, which means that the fluorinone, which is yellow, hasn't really moved too terribly much. I'm going to go ahead and switch to test tube number 3 now, and also switch the running solvent from hexanes to 70% hexanes, 30% acetone. So I'm going to go ahead and up the polarity of the solvent in order to get it to elute the more polar fluorinone from my column. So here we go. I'm going to switch these out. And so now I have in test tube 2, hopefully, pure fluorine is dissolved in here, but we'll figure that out by both TLC and melting point. And I will go ahead and switch and fill up with my 70% hexane, 30% acetone. Like that. And now what I'm going to do is watch the yellow color, because now this will elute the fluorinone from the column. I'm going to watch this yellow color until it gets down to about here, and then I'm going to switch to test tube 4 to collect my pure, hopefully pure, fluorinone. Okay, so I've been running 70% hexane, 30% acetone through, and if you see, try and zoom in, the yellow color is now down here at the bottom instead of where it started up at the top. So I'm going to go ahead and switch to test tube number 4 now, and hopefully collect my hopefully pure fluorinone, with again running with 70% hexane, 30% acetone. So I just want to quickly show you what the column looks like after the fluorinone is eluted. So you see that there's not really any more yellow color on the column itself. In test tube 4, the solution that I collected is actually, I don't know if you can see that very well, but it is a yellow color, which indicates that the fluorinone is no longer on the column, but is rather in test tube number 4, which is where I wanted to collect it. So I'm done collecting fractions from the column. I have my 4 test tubes. 1, which shouldn't have anything in it because it's just hexane before I loaded the compounds. 2, which hopefully should have fluorine in it. 3, which might have a little bit of both, but it's sort of the intermediate fractions before the fluorinone was eluting. And 4, which hopefully should be pure fluorinone. So the way I'm going to verify what I have first is by TLC. So I'm going to take a TLC, or run a TLC of fractions 2, 3, 4, and then pure fluorine and pure fluorinone. So I'll send a picture of that, what that TLC plate looks like, so that you can analyze the purity or not of our fractions. I'm also going to take melting points of whatever it is that's in fractions 2 and 4. I'll show you how to do that in a little bit. So you might be wondering how we are going to assess purity by melting point, given that melting point is something that you usually take of a solid, right? Solids are things that melt. And currently we have things that are dissolved in solution, right? 2 and 4 here. The answer is that I'm going to take these 2 watch glasses here and just pour out the solutions onto them. The solvent that these are in is volatile enough so where it'll just evaporate over time. And then the solids that are dissolved in them will remain behind, and then I can just take a melting point of those. Sort of a crude way of doing this, but it's effective for these small volumes of solvent. Okay, so all the solvent is evaporated out of fraction number 2, that's this one, and fraction number 4, that's this one. So you see that there's some solid left behind in both of them, right? There's this sort of crystalline yellow thing in 4, and this sort of opaque white stuff from number 2. So what I'm going to do now is prepare a melting point sample. The way you do that is with these capillary tubes. Now these are different from the ones that we spotted with for TLC. They're actually sealed at one end of them. And what I'm going to do is scoop up some of the compound with this and then pack it way down at the bottom so that we only have a tiny amount of the solid left in there. So I'll do that with this one first. Sort of just scoop up like this. So you see there's some, I don't know if you can see that very well. There's some at the top there. That's this white stuff here at the top. And to pack it, I'm just going to take this hollow glass rod and drop my capillary down it like this. I'll do that a few times. And you see, what's happened is that just by putting it down there, some of the white stuff is collected at the bottom there. And you really don't need that much for a melting point sample. That'll be just fine, even that small, tiny amount. So I'll just go ahead and do that for the second one, for this yellow one as well. And then I'll show you how a melting point apparatus works. Okay, so this is a melting point apparatus. This is sort of down here, the place where you control what temperature you set it to, how fast you want it to heat, and things like that. Up here is the actual heating element in here. And there's a little slot right here where you can set in your melting point samples. So this is the one that I made for fraction number 2, which hopefully is fluorine. And then there's a little viewing port right here. I'll show you a close-up of that in a second. And what you do is just set it to start heating, maybe 5 to 10 degrees below the anticipated melting point, and put your sample in there, and you just watch it, and you can watch your sample melt, turn from crystals into sort of a liquid. And you record the 2 temperatures at which it starts melting, so you see it start to change into a liquid, and the temperature at which it finishes melting. And so usually you record a melting point range. You don't record a single point. And the breadth of that range will tell you something about the purity of your compound, as well as where that range actually is in relation to the known melting point of a compound that you're trying to assess the purity of. So this is I'm just trying to get a little close-up shot of the viewing window. I've put my sample in here. I've set the temperature to start at 110 degrees Celsius. The literature melting point of fluorine is 115 to 116 degrees Celsius, so I'm starting below that. And if I zoom in here, hopefully, you can see in that, so there's 3 slots in there. You can do 3 melting points at once. And this middle slot is where my compound is. I'm wiggling it right now. So the white solids that you see in there, when this melts, obviously will turn into a liquid. So that's what I'm going to be watching. I'll record the temperature at which it first melts and the temperature at which it finishes melting as the melting point apparatus heats up. So you can see it's starting to melt. The sort of droplets on the side are going right now, so it's at 116.2 degrees Celsius. And it's fully transitioned to a liquid. It's at 117.2 degrees Celsius. You can see it a little bit better if I really raise it up. That's all liquid in there. There's no solid left. So our melting point range would be 116.1 to 117.2 degrees Celsius. So here's the fluorine melting point. It's this yellow one in the middle. I have it set at 75 degrees Celsius, so again below the literature melting point of fluorine. And I'm going to start heating right now. Alright, so it's starting to melt. Some of the stuff on the side is sort of turning into some droplets now. The temperature is 81.1 degrees Celsius. And now it's fully melted. The temperature is 82.7 degrees Celsius. If I lift this up, you can see that that's all liquid in there. There's no solid left. So our melting point range would be 81